Hello everyone and welcome back. So now we're going to look at how we can create our own breaking rules for the constraints. But before I do that, I wanted to show you guys an example of the slider constraint in case you are interested in understanding the motion. And so I mainly focus on this guy, and I'm going to hit play. And you can see the pieces are only allowed to rotate certain degree. See how these guys rotated and then stopped, and then the sliding feature is that they're allowed to slide 1 and -1. This scene is exactly identical to the one I was using, so I didn't spend time to investigate why the other one didn't work, and I hope you guys understood the motion of this constraint. Cool. So let's go back. So we saw how we can use the strength to break the constraint, and we want to break these constraints using our own rules. And so the way we do that is using something called a sopsolver. And what a sopsolver is basically this context here. Whatever we can do in this context, we can do in a sopsolver, but it's inside the DOPS context. I know it's a little bit confusing, but once you get you understand how this thing works, it's very powerful. You can modify any data in DOPS using a sopsolver pretty much. So I'm going to put down a sopsolver, a sopsolver, okay, and you can see the hint already. Using this constraint solver, we can modify the data. So basically we're telling this guy, hey, import the data from here, apply my constraints, and then run this solver. And inside the solver we will be able to import any data we want from the DOPS, do our sop modification, and then feed it back into the solver. So let me try and explain something. So basically we have the sim, okay, and we're getting the sop constraint, I'm gonna call it CST, into the sim, and this only happens one time, okay. Then let's say it's a glue constraint, for example. The sim will modify that glue constraint. So now if we have geometry, for example, that we've added and all those primitives are connected, the sim will break them. And the way we access this new modified sim is using a sopsolver inside of DOPS. So the sopsolver, we can say, okay, I'm in DOPS, I'm gonna create this guy, and once you dive inside, you can say, I want to read this data. You can read that glue data and say, I want to change its position. I want to change this I want to change the strength, for example, of my constraint if it's below, I don't know, 100 in Y, for example. And so you can import the data inside the sim from the main sub context, and in DOPS you can modify it using a sopsolver and all the attribute wrangles and everything we have in the sub context. So you can import any data from DOPS into this context, modify it, and then we say, okay, now it changed, I want to feed it back into the solver, the main DOPS solver. And so it will read it back in and behave accordingly based on that. And so once we create this guy, it says what's the data name, and this is very important, and generally the geometry is what we need to operate on, and that's where Houdini puts all these primitives and points into. So that's the data type. And I'm gonna dive inside, and here there's another the DOP data type, and the first one is going to import the geometry for us, and this is, if I go back and hit play, the constraint is broken now, but that's fine. This will contain the points, but because it's broken, it's not gonna be visible for us here. But the one we're interested in is this guy. So if I go back up, because of the context we don't have any geometry in there, so that's why it was empty. It needs to be done at another level, but the one we're interested in is the relationship. So this solver, if I dive inside, it has these 4 types, and the one we're interested in is the relationship, and this is where Houdini stores all the constraint information. And if I view the points, these are my points from the constraint. These are the points, the out constraint points. Okay, and so what we need to do is, let's say I'm going to put down a delete sop here. Okay, I'm gonna change it by bounding box or by sphere. I'm gonna increase it and delete any primitive that gets into that. Let's make it small, into that radius. And then I want to import the data as it is, apply this delete, and then feed it back in. And this is what's going to send it. Basically, the node you view, it's what's going to be fed back. Okay, so I'm gonna hit play and see already that it broke beforehand because those points were already deleted, I believe. So if I hit play, you can see it's gonna break that chain. Cool. So what we need to do is we need to use other rules. So let me hit play a few frames, and let's go back inside. And if I middle click here, you can see we have new data type, and this one is called force. We have a new attribute called force on the primitive, and there is another one called distance as well. And so this force will give us the amount of force applied to those constraints, and we can use this rule to decide. You can use this force in an attribute wrangle to say, okay, if my primitive force is higher than X number, I want to do something. So let's put down an attribute wrangle, and let's say it's a primitive attribute. Let's say if at force is higher than 100, what I want to do, I want to change the constraint name, because I don't want to delete the points. I want to just change the constraint name, and I'm gonna call this pin broken. Okay, and because this pin broken, there is no constraint that has that type, it's not gonna do anything, but it's not gonna delete the points. So if I hit play, yep, you can see already those points, they hit the 100, they hit the mark, they hit this limit. Let's try and make it 1,000. Yep, beforehand. Let's try making it 10,000. Okay, so now it's better, but it's still dying. So basically, this is it gets to the artistic decision now. It's not technical anymore. You have, yeah, some broke because of that force. You can see now, we're creating our own rule to break the constraint. Yeah, this one broke because of that, because the force met our condition and it changed the constraint name. But I'm getting this this thing here called required data pin broken not found or the wrong type. This guy is complaining because it couldn't find a data to attach to that name. And so to solve that issue, we're gonna put down another constraint, and this called no constraint relationship. Okay, and this is basically to get rid of that issue and to make everything works as expected. So the data name is pin broken, and I just wanted to attach it to something so it doesn't complain about it. So if I hit play now, we're gonna get the same behavior, but we're not gonna get that issue anymore. Cool. So now we have an understanding of the constraint. These are the glue and the hard constraint are the one we're gonna be using to create our setup, and then we're gonna be creating our own breaking rules in the main to break the hard constraint. And so the next example I want to show is how to change this from these primitives into something using the Voronoi fracture, and I think after that we're gonna move on and start building everything for our main cathedral. Thanks for watching, and see you in the next video. Bye.